In this video, we're going to learn exactly why we need a CI pipeline in a software development process and how to build one that automatically checks your application code quality and automatically suggests fixes for any issues that it discovers in your code. And if you're a software developer, this knowledge is going to be absolutely valuable and useful in your engineering job. So make sure to stay till the end and work through the entire demo. And with that, let's get right in. Let's say you are in a team of software developers and you're working on a specific feature. And the Git workflow that your team is using is trunk-based development, which is a standard workflow in today's modern DevOps-driven development. So you always have the main branch in a releasable state that triggers an automated CI/CD pipeline whenever code changes are pushed into the main branch. So you have a fully streamlined release pipeline with no bottlenecks, meaning no manual intervention at any stage of the pipeline that deploys all the way to at least the dev environment. And if you have really good test coverage, maybe to the staging or even prod environment without any manual testing or code checks in the process. But for this to work, you need to have lots of tests to make sure what you are committing to your main branch can be deployed and released to the end users. So various tests should be run to test different aspects of the code changes that are about to be deployed. Now, what are those tests that we want to run in this release pipeline? You will have unit tests or integration tests that test your code logic with different inputs and parameters to make sure that it's able to handle different scenarios. You may have security tests to scan all your dependencies and libraries for known issues or scan your code for any hard-coded secret data or any security best practices in logic, which you actually learn this set of security scans and tests in our DevSecOps bootcamp, where we go into detail how to test various security aspects of your application, from code to Docker image, etc. And then finally, you also have code quality tests. So your application code may be working, so the functionality is fine, it may be even secure, but your code quality may be bad or unmaintainable. Let's say you have lots of code duplications because instead of putting things into function, you are just duplicating the logic in multiple places, which is a bad practice. Or maybe you are using old APIs, old library versions. Maybe you have introduced risk for null pointer exceptions in your Java application. Maybe you don't have a good test coverage for your code. So these are the tests for your code quality. And the code quality test is what we're going to see in the demo in this video using Qodana, which is super easy and a really good tool to validate various aspects of your code. So important to note here that trunk-based Git workflow is usually an ideal workflow to use, especially in DevOps-driven projects. However, in practice, a lot of teams actually use a different Git workflow, which is called a feature branch workflow. The core idea behind the feature branch workflow is that all feature branch development should take place in a dedicated branch instead of the main branch. And this way, multiple developers or engineers can work on a specific feature without interfering with the main code base. So you create a feature branch and make your changes there. And when you're ready to merge, you create merge request and all the tests will run on the merge request to act as a gatekeeper and decide whether the changes should be merged into the main, meaning whether those code changes are even in a releasable state. That's why we want to run those tests on merge requests before the code even ends up in the main branch. Because imagine your code merged into the main branch and then the tests ran. And they failed because your code had issues, so those issues were discovered and the pipeline failed. But other developer also merged their code changes and they had just one or two issues, but now even if they fix their own issues, their code changes cannot be released because your broken code is also in the main branch. So it will block all other code changes from going to development until you fix your code issues. And that's why we want to run tests on the merge request instead of merging it into main and then running the tests. Now imagine feature development takes longer and you have tens of commits. Now you're done. Your feature works. You have tested it a little bit manually. And now you're ready to merge it into the main. And you create a merge request, which triggers all the tests and so on. And those tests detect a ton of issues that you have introduced. So your code works, but you copy-pasted some code snippet from internet with very bad coding practice and even added some security issues to the application. Now you have to go and spend probably hours or days figuring out how to fix those issues. Maybe you built the whole logic with this library that is outdated or has known issues. So now you have to start over, find a new library, and write logic with the new library, test it again, and so on. But you could have saved yourself all the time if you tested your code changes right away on the very first commit, instead of collecting those commits and then running tests later on the merge request. So what if you had those tests running even before the merge request on every single commit in the feature branch? So you introduced a library, committed the changes, and immediately saw through the code scan that this library has issues. Then you made another change, again, commit and trigger pipeline that will run tests to see if your code changes are fine. If not, you can fix the issue right away and move on to the next one. And especially as a junior engineer, this actually lets you learn so much of programming best practices while you're developing because it gives you this feedback loop of what you are doing wrong. And that process of committing small code changes frequently and running tests and scans on them to identify any issues is called continuous integration, or CI. And the pipeline that runs those tests in order to discover any issues is called a CI pipeline. And it is a best practice to build CI pipelines for feature branches. So you aren't deploying anything in the feature branch, obviously. There's no CD, continuous deployment. You're just testing your code changes for any issues frequently to fix them early enough. And you also saw that we kept moving those tests earlier and earlier in the development process, which is a general concept of shifting left, or shifting automated testing left. And guess what? There is even an option to find code issues even earlier than in the CI pipeline of a feature branch. You already have this on your local computer as a developer. When you use IntelliJ IDE, for example, that has built-in code checks that show you while you are developing if you have written a dirty code, which can be cleaned up and made better or more efficient, or if you just created a code duplication. And those built-in inspections will even give you auto-suggestion to, let's say, update the library version to the latest or remove the code duplication and so on. Or if you have any linter extensions with whatever code editor you're using, you can also have that locally in your development environment. Now, of course, we can assume that some developers may ignore those highlights that IDE is showing, or they may not even know how to use those auto-suggestions. And that's why we want to have those tests in the pipeline to run automatically, because we don't want to rely on individual developers doing everything correctly on their local machine. So we want to centralize this process and automate it. And that's why CI pipelines are so important. So you notice that we have multiple places where the code issues will be detected, starting from local ID to feature branch CI pipeline, merge request pipeline, and even when the code gets merged into the main branch, it will run the same code scans and automated tests again. Because as I said, what if other engineers merged their code changes before us? Maybe there is an issue between that new code and ours. So we want to check on every step. Great. Now that we understand what CI pipeline is and why it's so important, let's build one to showcase how we can implement a fully automated code quality checks. For the demo, we're going to use GitHub Actions as our CI server to execute the code quality checks. And for the code analysis itself, we will use a tool called Qodana, as I mentioned, which has really good code quality checks and is really easy to get started with. So just to give you a quick overview of how it works and how those automated code quality scans will be done, as I mentioned, IDEs like IntelliJ, actually all IDEs from JetBrains, have these built-in inspections that automatically scan the code file by file and identify any code issues and show them in the editor and even suggest fixes automatically. And essentially, we want to have exactly the same thing, but in a centralized place like CI pipeline. And Qodana, which was also created by JetBrains, is using the same mechanism and inspections that are built in the IDEs. So it runs those inspections and identifies any code issues. And as a bonus, imagine you could fix those code issues automatically in the pipeline. So those auto-suggested fixes can be applied in the pipeline, where we can tell Qodana to actually create a merge request from the automatically suggested fixes, which then you or an experienced engineer can review and merge it into the feature branch to fix all those code issues. So we're basically automating the code quality fixes. And of course, we want this to work for different programming languages. And usually you would have dedicated tools for different programming languages. Good thing about Qodana, and a convenient thing, is actually that you can use it for basically all the popular languages like Java, JavaScript, Python, and so on. So you don't have to switch between different tools. So this is an open source project on GitHub, which I have forked in my own account so that we can make some changes, run a pipeline, and so on. And I have this project open in my IntelliJ IDE, so we're going to make the changes directly here. And there are two things that we need to do to run the pipeline with code quality checks using Qodana. These are two easy steps. The first one is to create a GitHub workflow. I have removed all the workflows from the existing project so we can create our own one and just focus on that single workflow. So we're going to create a GitHub Actions workflow right here for the CI pipeline that will run those code quality checks. And the second thing is that we need to create a Qodana configuration file called qodana.yaml that we will pass to that CI pipeline. That's it. Super simple to get started with this and to build our CI pipeline for code quality checks. Starting with qodana.yaml, since we are in IntelliJ, we actually have Qodana tool and all these configuration options built in the IDE. So tools and Qodana, and if I click on this option right here to try run Qodana locally, we get this auto-generated qodana.yaml file. So we can either copy this whole thing or it will just automatically save it in the qodana.yaml file right there, which is pretty convenient because we don't have to look up the boilerplate configuration. We will leave everything as it is, except for one change, which is the profile here. Profile is basically a group of inspections that I mentioned, like in IDE. If we go to settings and look for inspections, you have the list of the inspections for different languages, different databases, plus HTML and so on. And they are kind of grouped in a profile, and you can create your own profiles in IntelliJ, but it comes with a default profile. And this is the same concept because it uses the same mechanism. Qodana developers created a couple of profiles that you can choose from. So if I remove this, we actually have those three options. And depending on how deeply you want to go and how detailed analysis you want to do, you can choose different profiles. There's a starter one, which is checking the most obvious issues. It's kind of lighter version, doesn't go really deep into the code. And then we have the recommended one, which will execute way more inspections against our code. So it will, of course, detect more issues. So let's choose this one, actually. Also, the name suggests that it's the recommended one from Qodana developers. And that's our Qodana YAML configuration. Right here, you see the linter, which basically is referencing a Docker image that will be used to execute the analysis on all the Java-related files and configuration. If you had a JavaScript project, then you would use another linter, which is for JavaScript. And you can actually see all these images in Docker Hub. We can search for Qodana, for JavaScript, JVM, PHP, Python, and so on. So if you had a JavaScript project, you would simply use the Qodana.js linter, which will analyze JavaScript or TypeScript code. So let's set it back to JVM. Qodana YAML configuration is ready. And now we can also let IntelliJ generate code for Qodana scan in a CI pipeline. So what happens if I click here? We actually get options for different CI/CD tools like GitHub Actions, GitLab CI/CD, TeamCD, and so on. So you can choose whichever CI/CD pipeline you will be running. Since our code is on GitHub, we're going to be using GitHub Actions, of course. So that's the code we need. And again, I'm going to just edit directly to the project. And right here, we have Qodana code quality.yaml. So that's also pretty convenient that we get the configuration for CI pipeline from the IDE, so we don't have to write it from scratch. And it, of course, automatically uses the Qodana action for GitHub Actions, which behind the scenes is executing all the Qodana scans. And by the way, if you're new to GitHub Actions, I actually have a separate complete course on GitHub Actions, the architecture, the syntax, how to write pipeline jobs, everything in detail explained there. So if you want to understand all the syntax, then you can actually watch that video. But essentially what we're doing is that we're defining that whenever someone pushes to the master branch, which is the main branch of this repository, or there's a pull request, then we want to execute or trigger this workflow. And I'm actually going to specify here to trigger the workflow every time there is a pull request to be merged into the master branch or the main branch. And in the job section, we just have one job called Qodana, which runs in Ubuntu environment, and it has two steps. One of them is just standard action to check out the code because it needs the entire code so that it can analyze all the files in the code. And the second one is the actual Qodana scan, which is using Qodana action from GitHub Actions with a specific version tag. And notice that we also have this token or a secret token here as environment variable that is passed to the Qodana scan. So what is this about? So the thing is, it's great to run code checks and automated tests to identify any issues. But let's say we have 50 issues that were identified. Going through them in logs is not going to be convenient. When we run automated tests or code scans, we always want to use a visualization tool with a UI where we can see the issues in a nice overview per file with description, maybe with a suggestion on how to fix it. We want to be able to sort it based on the level of severity, like how severe the issue is it critical, is it low, minor issue, and so on. And there are such tools where you can import the test results. In case of Qodana, it's actually simpler because it comes with its own cloud platform with a UI where you can see the code issues that were discovered with Qodana scan. So we can connect our project to Qodana Cloud, and it will automatically upload the results of each pipeline run or each job execution of the project to Qodana Cloud. So we can see the results there. And it's very simple to do as well. The way we do that is we go to Qodana Cloud and create just an empty team. And as you see, I don't have any projects here. I'm going to create a project. And all I need to do here is basically just drop in the HTTPS URL of the project. So I'm going to copy it from here. Next. And there you go. So now I have connected my project to Qodana Cloud. So Qodana Cloud knows about the project, but I also need to tell GitHub about Qodana Cloud so that it will send the results of workflow execution to Qodana. So it needs to be a two-way connection. And that's why we need the token that is displayed right here. So I'm going to copy that. So that's the token. And that's exactly what is referenced right here. And in GitHub Actions, the way you create environment variables, which are sensitive data or secrets, is very simple. We just go to settings. And then here we have secrets and variables for GitHub Actions. And we just create a new repository secret. I'm going to paste in the token from here, and we're going to call this Qodana token, which is referenced right here. So this way, GitHub will have an access credential, basically, of Qodana Cloud to authenticate with it and send the Qodana scan execution results, which will be displayed in Qodana Cloud. So I'm going to add the secret, And that's it. We have configured our pipeline. We have our code scan. So now I'm just going to commit these changes. I'm going to use a terminal from here. And let's push the change. So now, there you go. You see that the workflow was automatically triggered. And inside that, we have Qodana job that will run Qodana scan that is using this JVM image. Let's wait for this to complete and we'll see the results. So our job has completed. And as you see, it was successful. Let's check the logs first of all. And right here, we see the summary of the scan. We have 91 problems detected with different severity levels. And these are some of the issues. But as I said, checking the issues in the logs is actually pretty inconvenient. So we want to have a nice UI overview. The first one we get is within the GitHub itself. So if I jump in right here, we have the UI visualization of the issues, again, with different severity levels. So it has detected invalid YAML configuration with 47 problems. But of course, we want to see details of where each one of those issues are coming from, which file it is, what is the issue, and so on. And you also have them here in a long list. But as I mentioned, we want to check Qodana Cloud, and we have this link to detailed Qodana report conveniently. So if I click on this, as you see, we have a nice display of all the issues right here. And these are actually coming from this view. The project that we connected now shows an overview of the last run of the pipeline. So every time we run the pipeline, it will actually save those runs here. And we also see that 661 different inspections were done and all these problems were discovered. And we can actually click inside each issue and see exactly which file it comes from, what the issue is. We can also filter. Let's say we want to see those high severity issues. So now you see a more diverse set of issues, like visibility issues where a class is exposed outside of defined scope, or configuration property cannot be resolved. Some improvement suggestions in the code, like this one here that doesn't check is present before it calls optional.get method, and all these other issues. So now, of course, you can go through each issue one by one and try to resolve it. In many cases, try to understand whether it is an actual severe issue or not. So again, if I zoom out, we have some moderate problems. And let's go to moderate problems, and we have some code duplications here, and so on. And finally, we want to configure that auto fix feature that Qodana offers, which I personally find really cool. So I want to show you how it works. And it's actually a pretty easy configuration. All we need to do is set some parameters on our Qodana job to the Qodana action. So I'm going to paste in the configuration. So we're going to execute this Qodana action with argument apply fixes, and those fixes will be pushed as a pull request in our repository. And we have this attribute called PR mode here that we're setting to false. So PR mode basically defines whether only the changed files should be analyzed in the pull request. And by default, it's set to true. So we're going to set it to false to analyze not only the changed files. And by the way, you can actually find all these configuration options in the Qodana documentation as well. So for GitHub Actions, you have these arguments here, including PR mode, push fixes. So you can see here what other configuration options are available. And in order to allow this job to actually create a pull request in the repository, we're going to give it permissions or write permissions to create the pull request. And alternatively, you can actually configure this autofix directly in Qodana.yaml configuration file. It's called fixes strategy. And we have these options. We're going to choose apply. So we're telling Qodana to actually go ahead and apply those automated fixes that it suggests. And for this feature, we're going to use a specific image version instead of the latest. And now let's see how that works. I'm going to commit this. add autofix. And this should trigger the pipeline. And as you see, after a pipeline execution, a new pull request was actually created by Qodana. Which has code changes to fix those issues that it detected, like making some variables final or getting rid of the if statement where it was not needed. It actually removed some comments from the code as well. And in some other comments, it made the link a clickable link. We also have this Java file where it actually imported a library called Lombok to use setter and getter annotations instead of writing the setter and getter like this, which again makes the code cleaner. Another example of using Lombok. It added some null checks to the parameters. And again, as I said, if you are a junior developer, usually the workflow would be that you or another engineer in your team will go through these auto-suggested fixes and you can implement them or merge them into your code. Now, again, as I explained at the very beginning, this would run in a feature branch to scan your commit in the feature branch, and Qodana will create the pull request to merge into the feature branch again. So all of this is happening before the code even gets to the main branch. So that's basically how all this works. And if I refresh this, you see that another column was added with the list of issues. So you kind of build up a history of how many issues were discovered, whether it's declining or it's increasing. So you'll have all those code scan runs listed right here for a nice overview. So that's basically how you create a CI pipeline that will completely scan your code and identify any code quality issues and even give you fix suggestions that you can directly merge back into your code. Now, I hope this tutorial actually helped you to really understand why CI pipeline is needed. And as one of the steps that we execute in the CI pipeline, which is code quality check, how we integrate a tool like Qodana or basically any other tool in your CI workflow to give you a feedback loop and help you maintain good quality of your code. Especially if you have a large team and everyone's doing their own thing and you have junior engineers who are committing their own changes. So you have this centralized automated process or workflow to help each engineer keep their code changes in check instead of having all the senior engineers checking the code that junior engineers are committing. But if you want to dive deeper and start building real-life DevOps pipelines for releasing your applications, I actually have a complete GitLab CI/CD course on it, which I have linked in the video description. So if you're interested, you can check it out there. Let me know if this was helpful for you in your daily engineering work. And with that, thank you for watching and see you in the next video.